and hopefully Rachel will be here soon.
You'll join us, yeah. The
Any
assignment
questions?
this week was rough.
Oh, wait, what?
I said the assignment was rough, kind of.
Yeah, I thought so too during parts. It was just weird.
Yeah.
No offense to whoever created the assignment.
Well, but still, like, it was just, yeah.
Yeah.
I feel like, especially, so in the prep, like number 3, how to do like the 40th percentile, that took me forever and ever to figure out.
Oh, yeah. I actually skipped that one.
Oh.
Yeah. Is that like what we did? I had a question on this. Is that like what we did like way a long time ago?
Mm-mm. It's like
No?
similar, but not the same.
Okay. Hey!
Hi.
It was a lot easier just texting me the link. I was like, oh, type it in. Done.
Okay, cool. Yeah, I'll just do that because that's what I do for Caitlin.
Yeah, that's a lot.
Cool.
I was doing the assignment. I was
What?
doing the assignment. It actually wasn't too bad. I think going back to the old stuff and then doing the new stuff was a bit confusing for me, but I think I got it. I ended
That's
up
what you're
getting it.
kind of talking about.
Yeah, that's what we were just talking about too. Yeah, once I got to part 2, I was very confident.
Yeah,
And then
part 2
after
wasn't bad.
in questions 1 and 2, I was confident. Yeah, it was just question 3. I like looked at that, and then I probably should have finished it, but I just was like, I don't really
For a while.
know. So then I just moved on.
It ended up being, I think it ended up being the simpler equation from like lesson, was it 5? Okay, well, probably not. Today anyway.
Yeah. Okay. Well, any questions or anything to talk about from the homework or from the prep assignment?
Sure, we'll have to find some while we do the quiz, but
Sounds good.
I think so. I think my only question was if it's not distribution and you don't have a large.
I can't really hear you.
Yeah, you keep cutting in and out.
I talk closer to the speaker. Can you hear me now?
Yeah.
Okay, I'll just get closer. So if we don't have a normal distribution, like if it's right skewed or left skewed, and we have a small sample size, we can't calculate it, right?
Yeah, I got that wrong on the pre-thing or whatever, but I think that's how it is.
Okay. Because I know that will trip me up later.
Yeah.
Because I think I can calculate it, but I'm just making sure that we actually can't.
Yeah, I don't think you can.
Okay. Okay. Yep, well, I think I'm good.
Okay.
Yep. Okay.
Yep.
Yep.
Yeah. Just making me sign back in. We're on lesson 7.
Yeah.
Okay, yep, I'm there.
Okay. I can read question 3.
Okay.
use the normal probability applet to find the combined area under the standard normal curve that is right of z equals 1.358 and to the left of z equals negative 1.358. So what I believe you do for this one is you go to your applet and you put in your 1.358 and you enter, and then you select the left and the right, correct? Because it's saying to the left of and to the right of.
Mm-hmm. Yeah.
And then 0.175.
Yeah. That's
What
what
do
I
we-
got.
Okay.
Oh yeah, if you're rounding to 3. Yes. I was like 1745. What? Yep. We're good.
Oof.
Oh.
Did anyone see me almost fall? No? Okay, good.
Okay, I'll go for number 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn? Oh, okay. The distribution of the individual observations X, the distribution of the sample means, or cannot be determined. Oh, I don't even know what it's asking. Hold on.
I have a guess, but it's such a guess. But I don't think it's a guess.
Is it with the law of large numbers? One of those rules? Where if the sample size increases, the standard deviation of the sample mean decreases? So
Well, good to me.
So like as you get more and more samples, then the mean of all the samples gets closer to the mean of the population sample.
The population.
Yeah, population mean. So I'm guessing the second one?
I have the second one, and the way that you say it makes sense. And my reason for that was just because as we find that answer, it's usually smaller than the other X, than the X. So I think the way that you said it was math, and the way I said it was not math.
They both are the same, right?
Okay.
Yeah, that's true. Yep. Okay, then question 5. Which of the following results implies that the spread of the mean decreases as the sample size increases? Like what? So the
That
spread.
is what you just said, right? Isn't that the law that you just said for us?
I think so, but is
So
it backwards? Okay, now I'm turned around.
Wait, hold on.
Oh, yes.
I think it's law of large numbers.
Okay, so the spread of the mean decrease. So like the mean is getting smaller and smaller, and this because we're having more and more samples. Yes, I think yes. I think that's a lot of large.
The sample size increases. Yeah.
Yeah.
And if not, we know what it is next time.
Yeah. Okay, question 6. Scores on the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? And so for this one, we're just going to plug it into the z-score formula, correct? With those 3 numbers?
Mm-hmm. which distribute, it's like the x minus mean over standard deviation.
Yeah.
That one? Yeah, okay.
Yeah, so I think we do 150.8 minus 160 over 8.
Or isn't it the other way around? Maybe I'm mixing it up.
Oh, is it?
I don't know. I think so.
Let's find out.
Oh, well, that's what I was doing for the first part of the homework. So hopefully I did it right. Oops. Okay.
Value minus mean. Yeah. So it is 160 minus 150.8.
Hmm.
Divided by 8.
Just divided by standard deviation?
It should be for this one.
Hmm.
Okay.
Because we don't have a sample.
Yeah. So what do you guys get?
Got 1.045 and I kept going 4545.
Yeah, that's what I got as well. I'm always confused if you have to plug it in and get the other thing, but I think that's just the z-score for this one, right? Okay.
I'm sorry, say that again.
Oh, we're good.
Okay. Yeah, 1.045 is what I got.
Question 7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? That's when we use the applet to do probability, right?
Yeah.
So what do you guys get?
0.148.
Yeah.
That's what I got. Okay.
Excited.
Hopefully. Okay. So question 8. A random sample of 5 students was selected to take the GRE. Their students are 160, 175, 163, 149, and 153. What's the z-score corresponding to the sample mean of these students' scores? Oh.
That's where we have to find the mean first. Then we can find the z-score.
Okay, good. That's what I thought. And then I'm scared.
Oh, but then we have to find the standard deviation as well.
Yeah.
Okay, I might have forgotten how to do that, but I'll try.
So it's just it'll be the mean
Mm-hmm.
minus. Well, I don't know, because this is the part that is bugging me.
Standard.
Is
Oh.
does the new mean become the
Yeah.
well, they're the same, right? Hold on.
Well, because
No,
like
they're not.
in a normal distribution, the mean of the population is the same as the sample mean. They'll always be the same, but it's just when it's right skewed, left skewed, and we have a small sample size. That's when it would probably be different, but then we can't calculate it anyway. So
Okay, so then it'll be the. So it'll be well. Wait, have you gotten the mean for that one yet?
oh, working on it.
Okay.
Oh, dang it, I messed up again. Hold on. I keep typing them in wrong.
Oh, he's really good.
But then what I think we do is we find that, we do the top portion, and then we do that over 8.8 divided by square root of 5. That's the sample size.
That would make sense, but we still have a value.
That's
You know what I mean? We don't have x.
That's what I'm wondering, is if the new mean becomes the value. Thank you for giving me that word. If the mean of these 5 becomes the value.
Okay, and does that mean 160?
Yeah.
Yeah.
Okay, cool.
We can do it. I'm going to do it that way and see what happens. But it should be.
Okay.
Wait. So you're taking the mean is what we just got, and then the standard deviation, keeping it the same, the 8.8?
Yeah, standard deviation is the same.
Okay.
The mean is the same. What changes is the value, and we think it might be the new mean that we get, the mean from that sample.
Oh, because this is just a sample,
Yeah.
not the population mean.
I don't know. I don't know.
I don't know either.
So are we doing the 160 as the mean or the sample?
It would be the sample.
Okay, so we keep the same mean, the 150.8, same
Yeah.
standard deviation. Because then that would be the
But
same as question 6, right?
Except for we'd be looking for the standard deviation.
Oh, wait. Is this the new,
New equation?
yeah, the new equation where you put in the new mean or whatever?
I think, yeah.
Maybe?
I just don't really know how to do it.
Yeah, my problem is that I'm kind of guessing with that, finding that new
I know,
mean.
I've never.
But I
Okay.
just don't know how to get a value.
Mm-hmm.
If we don't have it, yeah.
Oh, but what it does say, this is what tipped me off. It says, what is the z-score corresponding to the sample mean of these student scores? I don't know.
Yeah. So what was your answer, Taylor?
Oh, sorry. I keep getting distracted.
Oh, no, it's okay. I thought you had it.
Does it remind me what the equation was for finding, did we learn an equation for finding standard deviation, or I forgot?
Yeah, it's the standard deviation divided by square root of the sample size.
Oh, and the sample size in this case would be 5, right?
Yeah, so it's 8.8 divided by the square root of 5.
Oh, okay. So it'll be the new standard deviation. Okay.
But that just doesn't seem right to me.
What'd you get?
2.38. No, 2.338.
Or, yeah. I got 2.338 as well. We
Okay.
did it the same way, but I don't know. I just don't know.
It doesn't seem like a normal z-score.
Doesn't.
It still could be a z-score, but it's big.
Okay, I'll hurry and do it real quick and see if it's the same.
She's going to be so mad at me, the teacher. She's going to be like, why were you saying all that stuff wrong?
What?
She seems so nice. I don't see her saying that. But Wait, did you get 2.337?
Yeah.
Oh,
Yeah.
sweet. Well, obviously we did something the same. If we
Yeah, just maybe all of us were.
No, but it makes sense though, because you're taking the old mean, old standard deviation, and just comparing it to this sample of a new mean and new standard deviation to find the z-score. So
Yeah.
that works as our answer. 2.
Yep. 2.338. So then for the next one, we have to plug something into the probability applet.
Oh,
Number 9, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the student?
4 decimal places.
Okay.
Oh, wait, I don't know. I thought you did it in the applet, but I don't know anymore.
I got 0.0097.
Okay.
Did you put it in the applet? Is that what you did?
Yeah. I just put our previous z-score.
So like the very first one or the new one that we just got?
Because you're comparing it to that.
0.0097. That would make sense that we're doing it right if they said the 4. If they asked for 4 decimal places.
Yeah.
Oh gosh, we shouldn't get our hopes up.
So you plugged in the z-score for the first, for question 6. The question 6 z-score? Question
No,
8.
yeah, the z-score we just got.
Okay, so you're using that one.
Because it's based on the 5 randomly selected students.
Yeah.
Mm-hmm. Oh, okay.
That's greater than the 1. Yeah.
And it was greater than that, right? So it's, I got 0.0097.
Yeah.
What?
Is everybody ready for the next one?
10. Oh wait, are we ready for that?
Mm-hmm.
Yeah.
Okay. Use the following information to answer the next 5 questions. Oh my gosh, there's 5 more questions. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. Which is the shape of the sampling distribution of the random variable which represents the sample mean of 81 students who are selected? Normal, right?
One I know.
Yep.
Okay. Woo!
Okay, 11. What's the mean of the distribution of samples for all possible samples of size 81 that can be drawn from the parent population? Whoa.
Okay, is that one self-explanatory or is it not? Or is it just like really easy or not?
Is the mean just 3.5?
I think so.
Yeah.
I
Because
don't
it's
know.
always the same. It just is worded weird. Ugh.
It has to be. We haven't learned anything that would say differently, right?
That's different.
Yep. I'm saying 3.5 as well. They just try and make it more complicated than it is to trip.
It's good for us. It's good for us.
Okay. Question 12. What is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So we just have to find the standard deviation for the sample size of 81, right?
Yeah.
0.7.
So that's standard deviation. Isn't that standard deviation over population squared? Square rooted, I mean?
Yeah.
Yep.
Okay. Oh, this is only small.
So I got 0.07 billion times 8.
Woo!
Yeah.
Yep. Okay, cool.
Okay.
Or what? 3 decimal places. So 0.078.
0.07. Yeah.
Yeah.
Is it my turn to read?
Sure.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 30?
Okay.
Okay, so this one, because we just did that other part, relatively easy, right? Okay, what was the original mean? So that's 3.5 minus 3.3 over 0.073.
Oh. I got a very small number.
I think I'm about to.
No, but that doesn't make sense. Oh.
I got
Oh wait, I got a really big number.
yeah, I got negative 2.5714.
I got 3.8.
Oh dang.
Whoa, okay. I did.
Oh wait, I just found the z-score. I didn't find the probability. Bad on me. So
Oh yeah. Okay, what did I do? Okay.
because it's less than. Yep.
3.
Less
Point,
than.
wait, it's 3.5 minus 3.3, correct?
Isn't it 3.3 minus 3.5?
I got 3.3 minus 3.5.
It's 3.3 minus 3.5. Okay, sorry.
Oh good.
Okay, so I got negative 2.56 when I did that.
So did I.
You did?
Oh, I got
Yeah, but
2.7.
then that's not the probability. That's just the z-score.
Yeah,
Yep.
so then you plug it in and I got 0.005.
Yeah, but that doesn't logically does not make sense to me. What's the probability that it's less that a GPA is less than 3.3, and that's
Oh yeah.
not even
but that makes
tenth of
sense.
a percent? I just don't understand.
So it's 0.5%. Because hold on, what's the mean again? Is 3 point, what are we looking at?
Wait, values first, right? It's value minus mean.
Yeah, minus.
So it'd be 3.3 minus 3.5.
Mm-hmm. What is?
Oh, which is what we did. Sorry.
Oh, because it's asking kind of in human language that normally the average GPA is, or whatever is 3.5. And then there's a difference of 0.7. So like it goes from like 3.5 plus or minus 0.7 in either direction, but 0.3. Anyway, so it's just asking how, like, is it, would it be, how do you put this in words? Is there a high probability of this to go down by 0.2 or not? I don't know. So there's a 0.5% chance or 0.0051 chance that it will go down to 0.3, or that the normal would go down to 0.3. Does that make sense?
Okay. That the mean would be 3.3.
Yeah, that the whole average would shift to 0.3.
Oh.
It makes more sense than what I was processing before.
I don't know. I feel like I need to do it over.
Yeah, it
again.
does.
Sure.
Yeah, might as well.
But I could be completely.
What's the probability?
Did you look at 0.0051 for that one?
I think I just rounded it. So I got 0.005.
Oh, it says 3 decimal places. Not 4. I always look at the 4, and it's just 3. So, okay.
I took it 4 as well. It's a good thing you said something.
Okay, well, the next question makes me question that.
Oh, dang it.
Makes you question our last answer. Me too. Because it's left skewed. And so I feel like, let's see what question. Question 13 should be higher than question 14.
Sure, okay.
I don't.
It says, what is the probability that the mean GPA for 81 randomly selected BYU students will be greater than 3.3? Okay. Wait.
Because I got 0.995. So the probability that the GPA of 81 randomly selected BYU are 99.5%.
Yeah.
Doesn't make sense to me. I got 0.995.
Yeah.
That's what I got too. Well, do you think maybe it's because there's a greater probability that it will be higher rather than lower?
Well, but doesn't it say that it's less skewed?
Oh, because if it's left skewed, it's the smaller
then
to the left, and the greater, like, so there's more people getting the scores on the higher end than the lower end. Oh.
Yeah, because it builds. That makes sense.
So in a way, it does make sense in my mind, because if there's 10 people that get higher scores and 2 people that get lower scores, what's the probability that you get a low score? Oh, if there's only 2 people, it's not that probable. But what's the probability of getting a high score? If there's 10 people already getting a high score, then I think your probability is probably higher. But I have no idea.
I guess when we turn it in, we can always come back and try again if we want to. But.
Yeah.
Oh, this boggles my mind.
I know.
Yeah, this one's tough stuff.
These are tricky. Okay. Number 15, do you want me to read it?
Yeah, go for it.
Okay. The United States Coast Guard assumes that the mean weight of passengers is 185 pounds. Sorry, I have to write these things down or else I forget. The previous value was lower, but it raised after a tragic boating accident. The standard deviation is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, that was observed in the sample. So it's just the right and left side. So we're comparing, right?
Yes.
Yes.
And it should be, wait, what was the sample size? 48? So it should just be plugging it into that formula.
Mm-hmm. The same one.
Oh, goodness gracious.
I have to like write it down on paper before I actually do it.
Yeah, me too.
185, right?
What?
185 doesn't matter? Is that just to throw us off?
No.Ait. No, that's the ugh, goodness gracious. I don't know.
That's the population mean, isn't it? And then the
okay, so it'd be
is the
that's the real one. So it's 177.6 minus 185.
Mm-hmm. Oh.
Or is it the other way? No, I don't know.
Because value is always first, right?
Yeah.
Or is it not?
No, values first.
Okay.
What? Now I'm confused.
Wait, why are you confused?
Oh, never mind. No, I'm okay. We'll figure this out. I think I was just confused at what you were saying versus what I was doing. Okay. Oh, wait, there's a note. Extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are also as far away from the mean. Desires in the positive direction. So that's just saying what you said, that we're looking on the left and the right, but not in the middle. Okay. Yep.
All right, I have an answer.
Me too.
Did you get 0.055?
Yes.
Yep.
Oh, what?
Nope.
Yeah.
Oh, you did?
Wait,
Yeah.
or didn't you?
Oh, Caitlin, you got it?
Yeah.
Okay, that's two.
Woo!
Oh, sorry.
Yay!
I thought you said no.
No,
Oh, that's
no,
okay.
I said yeah.
Oh,
Sorry.
pulling our legs. Dang.
Are we gonna try and submit this? Yes? Go to submit quiz. Okay, I submitted. Submit. Yes, submit. Oh gosh, I'm so nervous. What?
No, what?
Okay, what happened? I was double checking my answers. What happened?
We got a
Where did it-
0. Just kidding. We got 100.
What? Okay,
I legitimately, I don't understand how, but that's okay.
we are just awesome.
That is hilarious because I was like pretty positive that it was gonna be a 0.
0, 0, 0, 0.
Oh my goodness. Oh, yeah, I got it. Oh my goodness. That I think we understand what we're doing, but not at the same time.
Yeah, I think we're all like similar too in the fact that we all like second guess ourselves even when we know what we're doing.
Yeah. Where we know it, but then we're like, oh, but maybe it's not that. But
Yeah.
Yeah.
brain says it is, but then you doubt it.
Yeah. I hope that's how our test next week is too.
Goodness. Making my note page now, or have been.
Oh yeah.
Anyway, well, man, that was awesome. I'm so happy that that worked out. You guys are awesome.
Yeah, that was good. All right, well, see y'all Tuesday.
Yeah, thanks.
Yeah.
All right.
Thanks.
Bye.
Bye.
Weekend.